Welcome to a complete course in calculus. This is Tadessa. Let's see some applications of implicit differentiation. So what exactly is implicit differentiation? As you know, implicit differentiation means whenever we have mixed expressions, when the dependent variable and independent variables are mixed, we call it implicit implicit expression, and the way we will be using to find the derivative of the dependent variable with respect to the independent variable is implicit differentiation. So let's see this application. It says I have a triangle with two sides equal, and this S is nothing but constant always. So constant means it's always fixed, it's not going to change. And then I have an angle theta, which is included angle, and this is what is called the base. So this type of triangle is called an isosceles triangle. So for an isosceles triangle, if you draw an altitude height, that is going to be a perpendicular bisector. So perpendicular bisector means this guy becomes half of it, b over 2, and this is 90 degrees. That's what perpendicular bisector means. Okay, so again, it bisects the included angle here. So if this is theta, this guy should be theta over. So we have triangle 1 here, one piece, another triangle 2. So the question is, we want to prove that the area of this triangle is given by half s square times sine of the angle theta. That's what we want to prove. Okay, so how do you do that? The first question is, what would be the area of a triangle given the base and an altitude or height? Area is given by what? Half times the base times the height. That is a formula for area of a triangle. Okay, now we have to express this B and H in terms of S and an angle theta. It can be sine or cos, whatever. So we want to get rid of B and H. Okay, so B represents what? The base. H represents what? The height of the triangle. Now let's use, and by the way, these two triangles, T1 and T2, they are called congruent right triangles. Okay, they are congruent, which means the same, they are copy, and then they are right triangle because, you know, the angle here is 90 degree. Right triangle means it has 90 degree. So now let's use trigonometry. Now what is sine of this angle theta over 2? This angle here, you see, theta over 2. What is sine mean? Sine, you know, it is opposite over the hypotenuse. So what is the opposite? It's b over 2. B over 2 divided by, what is the hypotenuse? S. Okay, so which means what? I'm trying to find b. So this is the same as b. You know how to divide fractions. B over 2 divided by s means it will be 2s. So now if I have sine of an angle theta over 2 equal to b over 2s, how do I solve for s? For b? I will multiply both sides by what? 2s. So that will give me what? 2 times s sine of theta over 2 gives you what? The value of b. Now I was able to find b in terms of s and the angle theta. Good. Let's do the same thing for cos. So if I say, what is cos theta over 2? So cos is what? Adjacent divided by the hypotenuse. So for this angle theta over 2, the adjacent is what? H. So that will give me what? H divided by the hypotenuse is S. Again, you just multiply. So which means what? Cos theta over 2 is H over S. To find H by itself, just multiply both sides by S. So S cos theta over 2 equal to what? H. So I have the two formulas here. So which means I have to plug these two values here. So that will give me what? I'm sure you can see. Area is 1/2 times the base. What is the base? 2 times S, right? 2 times S sine of theta over 2 times H, which is cos theta over 2. Now, I'm going to use the double angle formula for sine. So you know that sine of 2 theta equal to 2 sine theta cos theta. Okay? So in particular, if instead of 2 theta, if I have sine of theta, this will be what? 2 times sine of theta over 2 cos theta over 2. This is what we call it, double angle formula. Okay. Now, you see here, 2 sine theta over cos theta over 2. I have sine theta over 2, cos theta over 2, and the number 2 here, right? So I have S, that will give me area equal to half S times S is S squared. The 2, this sine theta over 2, cos theta over 2 becomes what? Sine of theta. So we were able to prove that area is given by this. So using trigonometry. Now the question, the implicit, so far it has nothing to do with implicit differentiation or anything to do with calculus. Now the other part says, let's assume that the angle theta is increasing at a rate of half radian per minute. So theta prime, the angle theta is increasing at a rate of half radian per, so this is half radian per minute. So that is rate of change of theta. So it's given. Now the question is, what is A prime? Which is A prime means nothing but rate of change of area with respect to time when theta equal to pi over 3, for example. And then there is another part that says when theta equals pi over 4, but they are the same, just you replace instead of pi over 3, pi over 4. Now, what exactly is the question asking? This is what you need to understand. So what happened is, this is now what the area is, S theta. Now, as time goes on, this theta is increasing. So what happened? S is always fixed, constant. Keep in mind that. So it's constant means as time goes on, this is what's happening. You see, S is the same, right? But the theta is increasing. Then something like that. That's what was happening. S is the same. S is the same. B is increasing, of course, and theta is increasing. This is always the same. It's getting, this theta is getting wider. As theta goes wider, because S is constant, this guy goes, it increases. Okay, so what that means? I have this formula, area equal to half S square sine of theta. So which ones are functions of time? So if you want to be precise, area is a function of time. So what that means? As time goes on, the area, either increases or decreases. Okay, so we'll see that. Half, what happens, if theta increases, will the area increase or decrease? Half S is a constant. It has nothing to do with time, but theta is what? A function of time. So which means here I have a composition of sine theta and theta of t. Okay, sine of theta, sine of t and theta of t. This is a composition, okay, as a function of t, sine of t and theta of t. This is a composition. Don't forget to apply chain rule. So let's find the derivative. What is the derivative of a with respect to time? This is dA by dt, which is nothing but a prime. Okay, I'm using now implicit differentiation, equal to half S square is a constant. Now let's apply chain rule for this guy. What is the derivative of sine? Cos theta of t times the derivative of theta. This is theta prime. So theta prime is nothing but derivative of theta with respect to time. I'm sure this is clear. I'm using chain rule. So we're looking for a prime. It will be half a square cos, what is theta? When theta is power 3. That's what we are looking for, right? When theta is power 3. So when theta is power 3, this is power 3 times, and you are given that the rate of change of the angle is half radian per minute. So this is 1/2. So that gives me you half times half is 1/4 a square. What is cos power 3? Cos power 3 means 60 degree, right? So it will be half. So it will be what? 1/8 s square. That will be rate of change of area. So which means area is also increasing as the angle theta increases. So similarly for theta equal to power 4, you do the same thing. A prime, you just plug, right? Half s square cos power 4, which is 45 degree, times this is same half, right? So half times half is 1/4, right? A square cos power 4 is root over 2. So this will be what? Root 2 a square over 8. Thank you for listening. I'll see you in the next video.